Hi, my name is Cameron Pera, and I'm going to be talking to you about jets, about their engines, landings, and takeoffs. The F-15 has twin engines. They each have a high thrust-to-weight ratio, which means they're very maneuverable. Each engine generates about 25,000 pounds of thrust, which is 8 times their own weight. The usual weight of the airplane is 45,000 pounds, so the engines actually generate more thrust than the weight of the plane. 45,000 pounds is the loaded weight, so even with missiles and bombs, it's highly maneuverable. F-15s don't typically land on aircraft carriers, but it is possible. The Navy's FA-18 is, however, equipped for the intensity of those landings. It's a very high-impact landing, and it needs specialized suspension on the landing gear. When the aircraft lands on the carrier, it catches one of 4 wires as it lands with a tail hook. A tail hook is exactly what it sounds like, a hook on the back of the plane that'll catch the wire as it lands. There are 4 wires strung across the deck, each using hydraulics beneath the deck once it's caught. When it catches the wire, the airplane goes from 200 miles per hour to 0 to rest in 3 seconds, all in less than 500 feet. That is a deceleration of 66 miles per hour per second. You can see here how quickly it stops. As the pilot is landing, he or she pushes the aircraft to full throttle. So if something goes wrong, if the pilot misses the hook, or if the cable snaps, it can actually just take off again instead of falling into the ocean. You could hear that noise in the video. In the bottom right corner, you can see a diagram of the lighting system used to signal the pilots. Depending on his or her angle of approach, the pilot will see a different color and flash frequency of light. There's a 12-degree swing from top to bottom of the danger zones. Typically we think of green as good and red as bad, but in this situation both are bad. If the pilot is coming in too high, they'll see a fast flash or a slow flash of green, and if they're coming in at too low, they'll see a slow flash or a fast flash of red. The takeoff is very complicated, as when an airplane is taking off, it needs to have a certain amount of wind speed over the wing. The carrier actually moves into the wind to lower that speed needed for takeoff. The rest of the takeoff is powered by a catapult, which is steam powered. The catapult consists of 2 pistons inside parallel cylinders that are about as long as a football field, located underneath the deck. The pistons are attached to a shuttle that sits on the deck. The plane is attached to the shuttle with a tow bar. The catapult officer opens valves that fill the catapult cylinders with high-pressure steam that comes straight from the ship's reactors. Building up the right amount of steam is important, because if not enough is built up, the airplane won't make it off the deck and will be catapulted into the ocean. If there's too much pressure, the force will snap the nose gear right off. The catapult officer has specific formulas for how much steam is needed with various airplanes and various deck conditions. Once they're charged, the pilot blasts the engines. The holdback keeps it in place while they build up thrust, so they're not moving but the engines are revving up and building up thrust. And then the catapult is released and the plane is literally flung into the air. A 45,000 plane goes from 0 to 165 miles per hour in 2 seconds, with an acceleration of 82.5 miles per hour per second. And this is a video of a takeoff. You can see the crew member securing the shuttle. And now the pilot is building up thrust in the engines. And it's off. you can see that was a very short runway. It has to accelerate 100 to 165 miles per hour in just that short area. Thank you for listening. I hope you learned something.